Hi folks, in today's video we are going to be looking at rates of reaction graphs, how to read them and what they mean. So here we have a graph. We have two reactions. We have a pink/purple side and a green side. So the purple side is a fast reaction. Fast reaction will have high temperature, high concentration, small particle size or a large surface area and the addition of a catalyst. Whereas the green reaction is the slow reaction, so a low temperature, low concentration, large particle size, smaller surface area, or it doesn't have a catalyst. Now if you have a look at the graph, you can see that they both start and they both end at the same point. So what we mean by that is they've had the same mass or volume of reactant that has been used. It's just the fact that the green one takes a little bit longer to get to the end because it has a slow reaction because of those 3 or 4 different variables that we have. Here we have a graph where they are different. They have a different mass or a volume, and how do we know that? Well, it's because they end at different points. The green one is roughly half of the pink one, so say for example the pinky purple one had a gram of reactants, the green one would have 0.5 grams, so they still start at the same point but they end differently because the green one doesn't have as much available to react than the pink purple one. So we've got a couple of questions to try to see if this makes sense. We've got a graph that shows the reaction between marble and acid. You have to state when the reaction finishes. Now how do you know the reaction finishes? You're looking for this straight line here at the end. When it tails off, that's when everything's finished using up. So how do you know it finishes? Well, you take the end point, kind of roughly about here. You want to draw your line all the way down. Now it's best to use a ruler just so that you can get a nice accurate line. So it looks like it finishes at around 90 seconds. Now you're always going to have a little leeway either way. So someone could have wrote 89 seconds. Someone could have written 91. And for the second question, you have to sketch out a graph to draw a second curve where it's marble, chips and acid. So the question that the graph we've got is powder rather than chips. Now chips is going to have a larger particle size, so they're going to react smaller. However, it doesn't say anything about the volume, so you could probably draw your graph slightly slower with the curve just not as steep and make sure that it ends at the same point. And that would be your graph finished. And with these questions, we've got a lot of variables to identify which one's going to be fast or slow. So for the first question, you have to identify 2 experiments which could be used to the effect of concentration. So what that means is we're looking for these numbers here that I've highlighted. They have to be different. Everything else has to be the same. So if we take A for example, we've got powder in 20. Do we have anything else that's powder in 20? No, we don't. So we're not going to be able to use A. We've got ribbon in 20. Have we got anything else that's got ribbon or 20? Yes, we've got F. So let's compare B and F. They're both ribbon. They've got different concentrations and they are the same concentration. So you could say that B and F could be used to identify the concentration on reaction rate. With question 2, you're looking for basically just the fastest speed of reaction. Now you're looking for a high concentration, a high temperature and powder. So with A, we've got 20 degrees, which is okay. We can see if we can find anything higher. C has got 30 degrees, but it's got a low concentration. Whereas with E, we've got powder, a high concentration and a high temperature. So I would say E is the experiment with the fastest reaction. And that's a quick summary about graphs and rates of reactions and looking at some questions with graphs and some variable questions just to identify what reactants or what experiments are going to be the fastest.